Hi friends, very good morning to you all. As usually, this is your Virat Kumar, lecturer in electrical and electronics engineering. Today, we'll move into the part 2 of engineering curves. There's a point undergoing two types of displacements. So, in this engineering curves, in part 2, we have four different types of curves. First one is involute, second one is cycloid, third one is spiral, and the next is helix. All this may not be able to see in the one session. So, for today's session, we will just see how to draw an involute. So, previously we have seen about how to draw a normal and tangent to the conic curves in the part 1. We will just overview them. See, to draw a normal tangent to the ellipse and to draw a normal tangent to the parabola and hyperbola. So, now we will directly move into the type 2 curves of an engineering. Those are involute, cycloid, spiral and helix. Firstly, moving into the involute, we do have some different methods. The first one is involute of a circle. Comes again three types in it: straight length, which is equals to pi d, string length, not straight, sorry, string length is equals to pi d. Secondly, its string length is greater than pi d. Third one is string length less than pi d. So, this is the first method, involute of a circle, which involves again three types in it: string length is equals to pi d, greater than pi d and less than pi d. The second method is pole having composite shape. Pole having composite shape, that means it may be either triangle, square, rectangle, hexagon, pentagon, etc., etc. If a pole having composite shapes. The third one, a rod rolling over a semicircular pole. Rod rolling over a semicircular pole. Sorry. So, these are some common methods involved in making an involute. So, just note down the different methods to draw an involute, and slowly we will see one by one. Okay. See, there are slight definitions regarding all this involute, cycloid, spiral and helix, but today's our part is involute. So, we will just see the definition of involute. It is the locus of a free end of a string when it is wound round a circular pole. So, what an involute is called? It is a locus of a free end of a string when it is wound around a circular pole. For example, we will assume that there is some circular pole. If we wound some string, we have wound some string to that, we may wound some strings through that. So, it's a locus of a free end. See, from this end, if we cut this end, and if we open that, and if we if we cut that and it looks in this way, and it is the locus of a free end of a string when it is wound round a circular pole. If we open that, we may get a straight string of this. If we open that, so in order to, how we are just opening it, how we just wound it, so that part is called a involute. So we will directly move into the methods to make an involute. Firstly, involute of a circle. Similarly, in this curves, in this engineering curves part 2 also, will not move directly, will not go into the theoretical concept of this, will directly move into a problem and solve it. The problem number 17 in this session: draw involute of a circle. String length is equal to the circumference of circle. Draw involute of a circle with the condition that string length is equals to the circumference of circle. We know the formula for circumference of circle is 2 pi r or pi d. So the length of the string is also same as the circumference of circle. So we will see some relevant steps involved in it. We will see one by one. Point or end P of string AP is exactly pi d distance away from A, means in this string is wound around the circle, it will completely cover given circle. B will meet A after winding. See, we need to draw a circle with a given radius or diameter, divide that into some equal number of parts, say for example 8, and mention them 1 2 3 4 5 6 7 and 8, and at the last end you draw a horizontal line which is nothing but the circumference of the circle. Let that be A and P, which is nothing but 2 pi r or pi d, and divide this line also into 8 equal parts and name them as usually 1 to 8 and 1 to 8. So we are moving so forward. See, point or end P of a string AP is exactly pi d distance away from A. Means if this string is wound around the circle, it will completely cover given circle. B will meet A after winding. So now divide pi d of AB in distance into 8 number of equal parts. Similarly, divide the circle also into 8 number of equal parts. So name after A 1 2 3 4 etc. up to 8 on pi d line. AP as well as circles in anti-clockwise direction. So we have gone up to 4th step. Now extend the lines, or extend the perpendicular lines from 1 2 3 4 5 6 7 8 is already existing. These are some projection extending lines or projection lines. So they should be perpendicular to 1 2 3 4 5 6 7 and 8. Now so this is a 1 to P1, that's P2, P3, P4, P5, P6, P7, and last one is P. P8. Okay. Up to radius C1, C2, C3 up to C8. Draw tangents from 1, 2, 3, 4, etc. circle, taking distance 1 to P in compass and mark it on tangent from point 1 on circle, means one division less than distance AP. Name this point as P1. Okay, these are some two radius. So the center one circle C1, C2, C3 up to C8. Draw tangents. I have said you nothing but the perpendicular lines, nothing but the tangents from 1 to 3, 4, etc. up to the 8. Now take distance 1 to P in compass and mark on tangent from point 1 on the circle, means one division less than distance AP. Name this point as P1. Next take from 2 to P distance in compass and mark it on the tangent from point 2, name it P2. Similarly, continue the step, take 3 to P, 4 to P, 5 to P up to 7 to P distance in compass and mark on respective tangents and locate P3, P4, P5 up to P8. Up to P8. Now points and join them in smooth curve in order to obtain an involute of a given circle. So this is your respective involute of a circle. Okay, we'll see it again. Firstly, draw a circle with a given radius or diameter and divide the circle into some equal number of parts, say it 8, and mention the points in the anti-clockwise direction and draw the circumference of the circle with a measurement of pi d and mark it as AP. Divide this length into same 8 equal number of parts. As the circle is done, I'll mention the points 1 to 8. Now draw the perpendicular lines or the tangents to the circle from 1, 2, 3, 4, 5, 6, 7 and 8. 8 is already done. Now by taking your compass, measure from the circumference 1 to P and mark the point from the tangent on the tangent 1. So 1 to P1, 1 to P gets you P1. Similarly from 2 to P, measure the 2 to P in your compass and mark the point on 2 to P on your tangent. Similarly 3 to P, 4 to P and so on up to 8. Now you have obtained all the 8 points. So join all these points smoothly in order to obtain your required involute. So is it clear? So this is your required involute. Take 2 minutes of time and complete this. Okay, or else we'll move on to the next topic. Same involute of a circle with a string length more than pi d. The string length is more than pi d. So draw involute of a circle with string length is more than circumference of circle. See solving steps in case string length is more than pi d, but remember whatever may be the length of string, mark pi d distance horizontally along the string and divide it into 8 number of equal parts and not any other distances. Rest all steps are same as previous involute and draw the required curve completely. Same, taking a circle, divide it into some 8 equal number of parts, mention them in the anti-clockwise order. Similarly, draw the circumference with 165 mm more than pi d. So we know the value of pi d, and we'll slightly, since he's saying that the string length is more than the circumference of circle, so we'll extend the line and divide that line into 8 equal number of parts, mention them. This was the actual thing. Now we have extended. So same, from draw the perpendicular lines or tangents to the circle from 1, 2, 3, 4 and etc. up to 8. 8 is already done. So now same from 1 to P, mark the point on the one tangent line, same 2 to P on the second tangent line, repeat the same from 3 to P, 4 to P and so on to all the tangents. And now join all these points smoothly in order to obtain your required involute. So from the previous thing, the steps to make this involute is same, but the thing is only the string length is slightly higher or more than the circumference of the circle. So we have done with that. So this part is your highest than your circumference of the circle, and this is your pi d length up to 8. So that's the same. So all the procedures from the previous, where the circumference is equals to the string length, which is same, but the thing is only extending some part of line. The procedure is rest same. So shall we see it again? So draw a circle, divide it into 8 number of equal parts, I'll mention the in the anti-clockwise order. Draw a circumference of the circle slightly higher than the actual circumference of pi d. Similarly, divide the line into 8 equal parts. One to 8, and the rest part is your higher, more than the length of your circumference. Similarly, draw the perpendicular lines from 1, nothing but the tangents. Similarly to 2, 3, 4, 5, 6, 7 and 8 is already done. Now same 1 to P, measuring 1 to P in your compass. Cut the tangent line or mark the point on the tangent line from 1 and mark it as P1. Mark it as P1. Similarly to the second line as P2. Similarly to the third line as P3. Similarly to the fourth line as P4, fifth P5, P6, P7 and P8. Join all these points in order to obtain your required involute. This is your required involute of a circle with string length is more than the circumference of circle. Okay, now we'll move on to the next. So involute of a circle with the string length less than the pi d. Firstly, we have seen string length is equal to this pi d. Secondly, we have seen string length is more than pi d. And third, we are saying string length is less than pi d. So draw involute of a circle with string length is less than the circumference of circle. See, in this case string length is less than pi d, but remember, whatever may be the length of the string, mark pi d distance horizontal, therefore along the string, and divide it in 8 number of parts equally and not any other distance, and the rest all steps are same as previous involute, and draw the curve completely to obtain your involute. Okay, draw the circle. Draw the circle with a given radius, a dia, and divide the circle into 8 number of equal parts, and mention the points 1 to 8 in the anti-clockwise order, and draw the circumference line from the 8. So this is your 150 mm, which is less than pi d, and this is your actual pi d. Now divide the line into 8 number of equal parts of your pi d and mention the points 1 to 8, same, and draw the perpendicular lines or tangents to the circle from 1, 2, 3, 4 and up to 8. it is already done. Now by taking your compass, measure from 1 to P and mark a point on the tangent from the circle through 1. Similarly, measure from 2 to P in your compass and mark a point on the tangent to the circle through 2. So repeat the same from 3 to P, 4 to P, so on up to the end. See this from 3 to P, 4 to P, 5 to P, 6 to P, from 7 to P, and 8 to P. So now join all the points smoothly in order to obtain your required involute. See from here, from the point 8, we haven't cut any line towards right, we have cut towards left. It's so because from 1 to P all we have moved towards right, so we have cut all the tangents towards the right, but whereas from 8 to P it's towards left, so we have cut the point towards left. So this is your required involute with the string length less than pi d. Just take 2 minutes of time and draw the involute. So in this you need to differentiate among these three, like how to make an involute to a circle with the string length equals to circumference of the circle less than and more than. So firstly we have seen equal, secondly more than, and thirdly we have seen less than. So just differentiate them, understand them, how to make and draw your required involutes. The curve should be very smooth and fine and accurate. It should not be in a zigzag order or something. It should be sharp. Since the subject is a drawing, the marks may also involve to your neatness, not only to the diagram. It also involves to the neatness, how you are just making the diagram, what kind of pencil you are using, for which part, which type of pencil you are using. So the main thing which we require should be very dark with the pencil of 2B, and the rest should be very light. It should not dominate the required parts. Okay, this is the involute for the circles with the string length of same, less, and more. Next we'll see involute of composite shaped pole. So what is a composite shaped pole? Composite shaped pole may be not in a circle, maybe not in a circle, it may be some sharp ends, maybe like a triangle or a square or a pentagon or hexagon, or it may be in the combination of this order, so anything else. So now we'll see involute of composite shaped poles. See here, the problem number 20. A pole is of a shape of half hexagon and semicircle. A pole is of a shape of half hexagon and semicircle. The composite shape we took over here is half hexagonal and half semicircle. The semicircle itself is in half, so a pole is of a shape of half hexagon and semicircle. A string is to be wound having length equal to the pole perimeter. Draw the path of free end P of string when wound completely. Take hexagon of side 30 mm and semicircle of 60 mm diameter. Now there are some solving steps involved in it. Draw the pole shape as per your dimensions and divide the semicircle in 4 parts and name those along with concerned corners of hexagon, and calculate the value of perimeter length. Show it as string AB on this line and mark 30 mm from A. Mark and name it 1. Mark pi d by 2 distance on it from 1 and dividing it into 4 equal parts, naming 2, 3, 4, 5. Mark 0.6 on line 30 mm from 5, and now draw tangents from all points of poles from the semicircle in proper lengths as done in all previous involutes problems, and complete your required curve. So these are some solving steps to make a composite shaped pole. Now we'll just step into the diagram directly. See, if you observe the diagram, it is just looks like your half hexagonal and semicircle. So the combination of half hexagonal and semicircle. So these kind of shapes are called composite shaped pole. Now similarly, drawing a line, nothing but the AP, and dividing the semicircle in 4 equal parts and name them as 1, 2, 3, 4, 5, 6, 7, 8. See here, the division of the circumference line has got, see, A to 1 is this shape, and from here to here it's a semicircle, so that will be your half part in your circumcircle, nothing but pi d by 2, and the rest you can measure in your compass and mark the points. So this is your division of your string length. Now as usually we need to draw tangents from all the points of poles. See, from 1, so this is through A, this is from 1, so 1 it is directly a perpendicular line or a tangent to your circle. 2 it's perpendicular line and tangent to the circle through 2. Similarly to 3, 4, 5, and again from 6, and A is already existing. So these are lines. So to mark points, measure in your compass A to B and mark the point from A. Similarly from 1 to B, mark your point from 1 to P1 on your tangent passing through 1 in your circle. Similarly from 2 to P is from 2 to P, 3 to P is from 3 line, 4 to P is from your 4th line, 5 to P is from your 5th line, 6 to P is from your 6th line. So join all these points smoothly in order to obtain your required involute. So we'll see it again. Draw the given composite shaped pole with your halves hexagon and semicircle. Draw a horizontal line with AP and divide the semicircle in 4 equal parts and name them in anti-clockwise direction. And now from A to 1 is your this pink block, and from 1 to 5 that embed your half part in your pi d, that is this, and the rest are your 30 mm lengths of your hexagon. Similarly mark the points, that will be A, 1, 2, 3, 4, 5, 6, and last is P. Now extend the lines from A, and from 1, 2, 3, 4 and 5 you need to draw a tangent similar in the previous diagrams, that should be perpendicular to the line 1 and it should pass as a tangent to the circle through 1. Similarly to 3, 4 and 5, and the 6th line directly will be in a straight way, and the A is already done. Now with AP, measure AP in your compass and mark a point from A line. Similarly from the compass, mark 1 to P, measure 1 to P and mark a point on tangent 1, tangent of the circle passing through 1. Repeat the steps Similarly from 2 to p, 3 to p, and so on to the end. 3 to p, 4 to p, 5 to p, and 6 to p. Now you got points, all the required points. Join all these points smoothly in order to obtain your required involute. So this is your involute. This is your involute. Okay. Okay, we'll move on to the next. So problem number 21, the last method in your involute, which is rod rolling over a semicircular pole. So there is a question: a rod of AB, taking a rod AB 85 mm long, rolls over a semicircular pole without slipping from its initially vertical position till it becomes upside down vertical. Draw locus of both ends A and B. See how to solve some steps. If you have studied previous problems properly, you can surely solve this also. Simply remember that this being a rod, it will roll over the surface of pole, which means when one end is approaching, other end will move away from pole. So observe the illustrations carefully. We have drawn a semicircle, and from the diagonal we have drawn a straight line to the end, marking it as AB. And this value is your pi d. I am marking it as 1, 2, 3, and 4, and dividing the semicircle into 4 equal parts, and name them 1, 2, 3, 4. See the illustrations carefully. Now mark the tangents from 1, 2, 3, and 4. Which is nothing but A1 B1, A2 B2, A3 B3, and A4 B4. So he's telling us to join all B values and join all A values. Is it clear? So we'll see it again. Draw a semicircle, and to the end of your diagonal draw a vertical line of AB and mark the circumference on it by dividing into 4 equal parts similarly to the semicircle. Now draw the tangent lines to the semicircle passing through 1, 2, 3 and 4. These lines reflect similarly to AB values. From 1 it is A1 and B1, 2 A2 B2, 3 A3 B3 and A4 B4. Now join all the B values and join all the A values. See, now join A values. So this will be your answer for the given question. So thank you. It's up to the session. So today we have seen about all the involutes for the circle with the string length of equal to the semi circumference, more than and less than, and an involute for your composite shaped pole. And also we have seen a small problem like how a rod of AB of 85 mm long is rolling on your semicircle. We have drawn a involute to it. So I hope you have got all the points, all the illustrations. See once again the video carefully and make all the notes in your observation and draw your involutes in your sheets neatly. So thank you one and all. Have a nice day.